All right, let's get right into it. Today, we're going to talk about a really powerful little keyword in C#, base. Seriously, this thing is the secret sauce for building awesome, layered code that you can reuse. By the end of this, you're going to see just how cool and essential it is.
So, inheritance is all about not reinventing the wheel. It lets us build new classes on top of ones we already have. Just think about it like you're putting up a building, right? You start with a solid foundation, right? Then you add more specialized floors on top. Well, the base keyword, that's like the staircase or the elevator that connects your new floor to that solid foundation below.
Now, theory's great and all, but to really see how this works, we're going to get our hands dirty. We're going to build a multi-level ticketing system. This is the perfect way to see how base works in a real-world situation.
So here's the game plan. First, we'll hit the most important job of base, making sure the parent's constructor gets called. Then, we'll see how you can add to methods without rewriting them. After that, we'll touch on grabbing data from the parent. And finally, we'll see how it all comes together.
Okay, first up, and this is absolutely critical, we need to make sure that every new specialized ticket we make is built correctly on top of the original basic ticket. You've got to have the foundation in place before you put up the walls. So here's the puzzle we need to solve. We've got this new event ticket for, say, a concert. It has its own unique info, like the event name and your seat number. But before any of that, it needs a ticket ID and an issue date from its parent, the plain old ticket class. So how do we guarantee that the parent's setup code runs before the child even thinks about doing its own thing? And here's the code. On the left, we've got our ticket class. This is our foundation. It's got a simple constructor that takes a ticket ID. Pretty standard stuff. Now, look over to the right at our event ticket, which inherits from ticket. Pay close attention to that little bit of syntax right after the constructor.
This little piece of code right here, this is the magic. Base ticket ID. This is a direct order. It tells our event ticket, hey, before you do anything else, you have to run the constructor of your parent class, ticket. And, by the way, here's the ticket ID it needs. And here's the proof. When we actually create a new event ticket, just look at the output. The very first thing that gets printed to the console comes from the base ticket constructor. It's only after that's done that the event ticket gets to run its own constructor logic. It works exactly in the order we need it to.
And that really is the main idea here. The base keyword is our guarantee that objects get built from the ground up in the right order. The foundation is always poured and set before we start adding the fancy custom stuff on top. Okay. So we're creating our tickets correctly. That's a huge step. But what about what they do? Let's say we want to give them new behaviors without just throwing away all the useful stuff the parent class already does. So here's our next challenge. The base ticket class already has a perfectly good method called printDetails that prints the ticket ID. Our event ticket needs to print that same info plus its own details like the event name. We definitely don't want to just copy and paste the parent's code into our new class. That's messy and a nightmare to maintain. So how do we reuse it? And this is how we do it. In our event ticket, we create a method with the exact same name, printDetails, and we use the override keyword. But the real key is that very first line of code inside the method. This one line is so powerful. It's basically a phone call up to the parent class. It says, hey, I need you to run your version of printDetails right now.
So we're essentially borrowing the parent's functionality right before we add our own special touch.
And the result? It's just clean. When we call print details on our event ticket, we get this beautiful combined output. First, the details from the base class, and right after, the new details from our child class. It's seamless.
This is the whole point. We're not replacing what the parent does. We're building on it. We're extending it. This is how you write really clean, maintainable code. We're leveraging that foundation and just adding another floor.
All right, let's add one final layer to our system. We have a ticket and an event ticket. What if we want a new VIP ticket that needs some special insider access to information that's way back in its grandparent class?
So here's our final scenario. That original ticket class has an issue date property. Now, we marked it as protected. That means it's not public for the whole world to see, but it's also not totally private. It's like a family secret. Any class that inherits from ticket gets to know about it. So how can our new VIP ticket, which is a grandchild of ticket, reach all the way back up the family tree and grab that date? Well, check out the code for our VIP ticket. It inherits from event ticket. Now, look inside its own print details method. After it calls its parent and prints its own VIP perks, it just directly uses the issue date property. Just like that.
The reason this works is because VIP ticket is part of the family. That protected keyword gives it a special backstage pass to the members of its ancestors, like issue date. It can just use that property as if it owned it, and it's that invisible base connection that makes it all possible.
And this right here just illustrates the whole chain perfectly. When we tell the VIP ticket to print its details, look what we get. First, the output from its grandparent, the ticket. Then the output from its parent, the event ticket. And finally, the unique stuff from the VIP ticket itself, including that issue date it snagged from the very top. It's awesome. So you see, the VIP ticket is the ultimate example of this layering. It doesn't need to worry about how to create a ticket ID or print event details. It trusts its parents and grandparents to handle all that. It just inherits their functionality, uses base to call up the chain, and then focuses on its one job, adding its own unique value, the VIP perks. Okay, let's do a super quick, rapid-fire recap. The base keyword really has three main jobs for us. 1. It initializes, making sure the parent constructor runs first. 2. It extends, letting us reuse parent methods. And 3. It gives us access to the parent's protected data. Look, if you only remember one thing today, make it this. Base is the bridge. It's the bridge that connects your class to its parent. It lets you build these incredible complex classes on top of a solid, reliable, and totally reusable foundation. And that leaves us with one final thought. Every piece of code you write can be a foundation for something bigger and better. So now that you know how to use the base keyword, the only question left is, what are you going to build on it? Thanks for tuning in.